Hi, I'm going to go ahead and do a solution video for last week's 10.4 mini quiz. So the question was, the monarch butterfly is an essential to the pollination process of many native and farmed North American plants. These butterflies migrate thousands of miles over several months. The Florida Department of Forestry outpost in Hawthorne, Florida has been tracking their population since the 2005 migration cycle. So in part A, all they want us to do is represent the data on a scatter plot labeling the axis. So first, let's go ahead and label the axis. On the x-axis, it's going to be years, because that is the variable that's the independent variable. It's the thing that affects the other thing. So that's years since 2005. And then on the y-axis, you put your dependent variable. It's what depends on the other one. So the year affects how many butterflies there are. So this would be population in millions. Of monarch butterflies. So we're going to start with the first point is 0 to 96. I'll do it in blue. So in year 0, that's year 2005, there are 296 million monarch butterflies. That goes right here. And then we've got 334. So in 2006, there was 334 million. Next year it goes down to 231, 253, 96, 201, 145, 60, and the last one is 33. Okay, so there you have your scatter plot. We went 0, 296, 1, 334, and then so on through the graph. So our graph looks like this. To me, what we're looking at is this looks like you could put a straight line through it. The other options are quadratic. It doesn't go up and down like this. Or it could be exponential, and it doesn't look to be exponential either. It looks like this is pretty well defined by a straight line right through it. So then what type of model do you think it is? It's linear. And that's because it is a straight line. Alright, so we have a linear one. And it says, of the following choices, which equation is the best fit line for the data? So right here, the y-intercept, all of these y-intercepts are the starts. So this is the y-intercept is the starting population. Starting population. Okay, so this y-intercept of negative 320, this means that the population of the butterflies would start at negative 320 million. That's not possible. Same with this one. It couldn't have started at negative 320 million butterflies. It starts at positive 320 million butterflies. And then this one, the slope, tells you how much it changes each year. Change each year. How much does it change? Well, 34 million. Does it go 34 million up or 34 million down? Looking at this, each year, is it going up or is it going down? I think the obvious answer here is that it is going down, so it should be negative 34x plus 320, because each year it goes down 34 million, and it started at around 320 million in 2005. Now, what is the predicted population size for the year 2010? So x in this is the years since 2005. And we want to know what it is in 2010. How many years has it been since 2005 and 2010? It's 5. So x equals 5. And we just plug that in. Negative 34 times 5 plus 320. Let me calculate that real quick. negative 34 times 5 plus 320. That equals 150 million. And then it says, how does that compare to the real data? So we're looking at this right here. This would be 2010, because this was 2005, 2006, 2007, 2008, 2009, and then there's 2010. So in that fifth year, it actually was 201 million. So it was actual 201 million. 201 minus the predicted, which was 150 million, is 61 million less than actual. So our prediction was 61 million less butterflies than the actual amount of butterflies. That's terrible handwriting, but it's 61 million butterflies less than the actual number that there was in 2010. Alright, so you should have had 150 million and then something about how it was less than the actual to get the points on that one. Then what year is the population predicted to go extinct? Going extinct means that there are 0 butterflies left. That's what extinction is. So that means the number of butterflies, 0, is equal to our prediction, negative 34x plus 320. You can solve this for x to figure out what year we think it's going to go extinct. So we have to subtract 320 on both sides. We get negative 320 equals negative 34x. We divide by negative 34. We get x equals around 9.4. So we are 9 years past 2005. This is years after 2005. So 9 years after 2005 is 2014. And we would say it's somewhere in like the middle of 2014. Is when they would go extinct, because that's when that number makes 0 butterflies left. So it asked what year the population is predicted to go extinct. If you plug in 9.4, which corresponds to 2014, then you get 0 butterflies, and that is extinction. So that is the solution video for the 10.4 mini quiz. If you want me to do more of these solution videos, just let me know. I can start doing them for more of the questions that we've had. Otherwise, have a good day and make sure to keep up on your work.